The hub is the component at the center of the wheel that holds the spokes that connect it to the rim that allows the wheel to rotate. This video is about the function and terminology of the hub. For service procedures, see the Park Tool YouTube channel. Let's take a look at all the parts that can make up a hub. The shell is the outer section of the hub. It's the part when all the bits and pieces are removed. Hub shells are designed and manufactured for specific uses. Hub flanges are the section of the shell that secures and holds the ends of the spoke. Flanges may be drilled with holes for holding the end of a J-bend spoke. Flange sizes can be relatively large in diameter or small. The flange can also be designed to hold the end of a straight pole spoke. Finally, flanges can have proprietary shapes to hold unique spoke ends. The axle is the shaft that runs through the bearing system in the middle of the hub. Axles vary in their designs, including axles that extend past the dropouts and use nuts to hold the wheel secured to the bike. These are referred to as solid or nutted axles. If the hub is held on with a bolt rather than a nut, it's referred to as a bolt-on hub. The quick-release system is commonly seen on bikes with open dropouts that permit the wheel to pass out of and back into the frame. The system typically uses a 5mm shaft passing through a hollow axle. The shaft is threaded on one end with a lever-operated cam on the other end. The nut on the end of the skewer shaft allows the pressure at the cam lever to be adjusted. Through-axle hubs are used on bikes with closed dropouts at the fork and rear triangle. An oversized retaining skewer passes through the hub to connect the wheel to the bike. The skewer, though commonly called a through axle, is not the true axle of the hub. In this hub, we can see this is the axle that is turning in the hub bearings. And this is the through axle skewer that will hold it to the frame. In this front hub, here is the axle turning in the bearings, and here is the retaining skewer that holds the hub to the fork. The through-axle skewers can have external threads on one end, which matches the internal thread in the frame or fork. Or through-axle skewers may be held by bolts threaded into an internal thread on the axle. Common rear through-axle skewer diameters are 12 millimeters, while front through-axle skewers can vary between 12, 15, or 20 millimeters. Around the axle will be a bearing system that allows the hub shell to rotate. Designs can include the cup and cone system and the cartridge bearing system. The cup and cone bearing systems are made up of round ball bearings trapped between a cup-shaped bearing race and a cone-shaped bearing race. The cone is fitted to the axle. The ball bearings, cup race, hub shell, and wheel rotate around the cone. Bearing adjustments are made by moving the cone along the threaded axle. The cup and cone design can be found on quick-release and solid axle hubs as well as on through-axle hubs. Another bearing option encases balls between two bearing surfaces to form a cartridge bearing. These are then pressed into hub shells designed for the purpose. The outer bearing race rotates with the hub shell, while the inner race is fixed to the axle. Cartridge bearings are considered non-serviceable, and the entire cartridge is replaced when worn out. Lock nuts are the outer nuts on threaded axles. These secure the bearing adjustments of a cup and cone hub. Or they can secure the sleeve nuts of a cartridge bearing hub. Various spacers can be used inboard of the lock nut to position the hub in the frame. The end of an axle can be designed for an end cap, a piece that is pressed over the axle end. End caps can help the hub fit the dropouts and also take the load when the wheel is tightened into the bike. For a threaded through axle hub, the end cap also acts as a lock nut for the cone or sleeve nut. If the hub system was designed for it, end caps can be changed to permit the hub to work for a through axle system or an open dropout bike using quick release hubs. Hub seals are systems used to keep out water and grit from the internal parts. A cartridge bearing can use a pressed rubber piece fitted to allow rotation between the inner and outer races. A cup and cone hub can use rubber seals and boots to the same effect. Free hubs are the mechanisms built into the rear hub that allow us to pedal and drive the wheel, but then freewheel when we stop pedaling. Free hub bodies are cylinders with splines that match compatible sprockets called the cassette, sometimes called the cassette stack. Free hub systems are distinguished from freewheels in that the free hub body is secured or built into the hub shell. These are not removed from the hub shell except for specific free hub servicing. The design of the free hub spline patterns vary from brand to brand and from model to model. Both the width of the free hub and the spline pattern must match the intended cassette. Cassettes are distinguished from freewheels in that there are no ratcheting parts in the cassette. The ratchet is in the free hub. Freewheel hubs have a large external thread for mounting the screw-on freewheel. Freewheel is made of an inner and outer ratcheting body with sprockets attached. It has an internal thread that mounts on the hub body. The ratcheting clutch of the freewheel is not part of the hub system. Freewheels with their sprockets can be removed for hub service. In a fixed gear system, if the rear wheel is turning, so are the pedals. In this system, a right-hand threaded sprocket screws onto a thread on the hub. A smaller thread uses a left-hand threaded lock ring. Hubs used for disc brakes must have a rotor mount. This is the section adjacent to the hub flange that holds the rotor of a disc brake system. Rotor mounts can be made for a 6-bolt rotor system, or it may be a center lock system with splines on the hub matching the splines in the rotor. A lock ring presses against the rotor to hold it to the hub. There are adapters to permit mixing between types of rotor mounts. Internally geared hubs can use planetary gears built inside the hub shell. We've marked the hub shell and the sprocket with tape to show you the different gear ratios. Here, the sprocket and the hub shell are staying together pretty much like a 1-speed. Shifting gears, you can see the wheels moving much faster than the sprocket. This is your hardest gear, your fastest gear. In the easiest gear, now the sprocket is turning faster than the hub shell and the wheel. Electric motor hubs will have an internal motor fitted inside the hub shell. There'll be a wire coming out for the power that goes to the battery on the frame. Typically, there are no user serviceable parts in an e-motor hub. For two hubs to be compatible, there's a few features that need to match. First, the two attachment systems should be the same. For example, on a bike made for through-axle systems, it is not going to accept a quick-release hub made for open dropouts. Next, the hub width should match the frame. Hub width is measured from the points where it contacts the dropouts. On a quick-release style, it is the face of each lock nut. But for a through-axle hub, it is simply from the face to face of each end cap. Another consideration is that the hubs must be compatible with the gear system on the bike. A bike required an 11-speed stack on this older free hub. We can see this last sprocket is engaged on nothing. It is not going to work. This one won't be compatible. Finally, the braking system needs to be compatible with the hub. This is mostly applicable with disc brakes needing a disc brake compatible hub. There's always going to be unique hub designs, such as this one that attaches only from one side. The key to understanding a hub service is first to understand how they work. When in doubt, contact the manufacturer. Thanks for joining us. For more hub content, see our Park Tool YouTube channel.